All right, today's lesson we are talking about slope. The TEKS for slope are A.3a, determining the slope of a line. Okay, so we're going to be finding the slope of a line a few different ways. The first way is if they're given a graph. Okay, if we are given a graph, we want to pick 2 points on that graph and just count the rise over run. You guys should remember this from Algebra 1, so this shouldn't be anything new. Okay, but we're just going to refresh. So we read slopes like we read a sentence. Okay, we always start from the left and we work our way to the right. So if the slope from left to right is going upwards, we call that a positive slope. If the slope from left to right is going downwards, that's a negative slope. If our slope is perfectly horizontal, we call that a zero slope. And if our slope is vertical, straight up and down, we call that an undefined slope. Some of you may have been taught and may remember we have what we call the slope man. It helps you remember where we've got our positive slope, negative slope, our undefined slope. We put a U here for undefined slope, and we have our zero slope. Okay, so if that helps you remember. So if we're looking at some problems here on our assignment, some of them, like number 1, they already give you 2 coordinates to choose from. All right, we're just counting the rise over run there. But if you look at problems like number 3 and number 4, actually, they don't give you coordinates to use. So you have to choose your own coordinates. Okay, it doesn't matter which coordinates you choose as long as you choose good coordinates. So I can choose a coordinate here. I can choose a coordinate there. It does not matter which 2 coordinates I use. I'll end up with some sort of fraction, because we're talking rise over run. I'll end up with some sort of fraction, and if the fraction reduces, then I need to make sure that I reduce. So from one coordinate to the next, I'm actually rising 1, 2, 3 units. I'm rising 3 units, and I'm running horizontally 1, 2, 3 units. Okay, so, and obviously the fraction 3 over 3 reduces to 1. So my slope is 1. Now, however, this slope, reading from left to right, is going downhill, like Jacob should be doing while he's playing linebacker, playing downhill. Downhill slope tells us that that's actually a negative slope, so our slope here is actually going to be a negative 1 for that problem. Now, let's say they don't give you a graph. Okay, let's say they just give you 2 coordinates to choose from. Okay, so we're going to use what we call the slope formula. y1 minus y2 over x1 minus x2. Okay, so from our 2 coordinates they give us, we're going to identify what are the x values of that coordinate, what are the y values of that coordinate, and we're just going to plug them in here. And I want you to make sure that you are using parentheses when you're plugging these values in. If you don't use parentheses, you are likely to make a mistake. So please make sure that you use parentheses when you're using the slope formula. All right, so if we're looking at problem number 6, I've written down the slope formula just so we remember it, y1 minus y2 over x1 minus x2. This is like my rise, because the y-axis is the one that rises, and the x values are my run. Okay, so it's still rise over run. It's like we're counting from one coordinate to the next. We're trying to find the change, the distance that we rise, and we're trying to find the change or the distance that we run. Okay, so I've got my 2 coordinates here, 19, negative 9, and negative 16, negative 9. So what I've done is I've labeled those for us. Okay, I want you to get in a habit of doing this. Okay, the first coordinate in my ordered pair is the x value. So 19 is my first x value. Negative 9 is my first y value. Now the second coordinate, negative 16, is my second x value that they give me, and negative 9 is my second y value that they give me. So what I want to do is I just want to rewrite this slope formula using parentheses. And I'm just going to plug in the numbers that we're given. So my y1 is going to be negative 9. My y2 is also going to be negative 9. So make sure you put negative 9 inside the parentheses. Okay, this minus sign is part of the formula. You have to have it there. Now we go my x1, which is 19, minus my x2, which is negative 16. Okay, so we'll come down here and I'll work this out. So negative 9 minus negative 9. I would encourage you to put this in your calculator just to double check. Okay, put it in just to double check. Negative 9 minus negative 9 actually gives us a 0, because that's a negative 9. Back-to-back negatives here turn into a plus. So it's like negative 9 plus 9. My denominator, 19 minus negative 16. It's like 19 plus 16, and 19 minus negative 16 would be 35. Okay, now we're going to get a fraction. We need to reduce this fraction. As long as 0 is on the top of our fraction, we're good. The answer there is going to be 0. If 0 is ever at the top of your fraction, then it's going to give you a 0. Plug it in your calculator. 0 divided by anything, you're going to get a 0. If the 0 was on the bottom of your fraction in the denominator, you try to plug that in your calculator, it's going to give you an error. If you get a 0 in your denominator, which gives you an error, that tells you that your slope is undefined. Anytime you have a 0 in your denominator, that's where your slope is undefined. 0 in the numerator, your slope is 0. And obviously, if you get any other numbers here that are not zeros, you will reduce the fraction if possible. Let's see what else we've got. All right, moving on to graphing lines. When we are graphing, we always want to make sure that that our equation is written in slope-intercept form. Okay, slope-intercept form is, you should be familiar with it, y equals mx plus b. So we always want to solve for y. If our equation is not solved for y yet, we want to solve for y. Okay, you should remember this from Algebra 1. This is called slope-intercept form because as we look at this, the coefficient in front of my x variable, which is my m in this case, that's my slope. And then my constant at the end, my b value, that's my y-intercept. Make sure you understand that's the y-intercept, not the x-intercept. Okay, so once we have it in slope-intercept form, y equals mx plus b form, we're always going to plot our y-intercept first on the graph. So we'd plot our b value, whatever this number is, we'd plot that first. Then once that's plotted, then we can look at our slope and we can count rise over run to plot our slope from there, whether it's positive or negative. Okay, so if we're looking at problem 14, there's a little bit of a typo. You can't quite see that this is actually a 3, so make sure you put this as a 3 on your paper. The first thing we want to do, like I said, is solve for y. If I'm trying to solve for the y value, the first thing I need to do is get rid of the 3x. How would I do that? I would subtract 3x. I want the whole thing to go to the other side. So we subtract 3x from both sides. So I've got 4y. Now I want to put my x term in the front because if you look at your intercept form, your x term goes to the front, constant to the back. So here I'm going to put my negative 3x in the front, and I'm going to put my minus 16. I'm just going to move him to the back. All right, now still need to solve for y. So the last thing I do to solve for y is I'm going to divide by 4 to get the y by itself. Now when I divide one number by 4, I'm going to do it individually, and we're going to divide everything on the right-hand side by 4. So I've got y equals negative 3 over 4x. Now negative 16 divided by 4 gives me negative 4. Once I have it solved for y, now I can graph. Like I said, we're going to plot the y-intercept first, which is negative 4. Y-intercept. Make sure you plot your negative 4 on the y-axis. A very common mistake is that you guys accidentally plot this y-intercept over here on the x-axis. Plot it on the y-axis. Now the slope is negative 3 over 4. So we're going to go down 3, 1, 2, 3, over 4, 1, 2, 3, 4. This one goes off the graph, but that's okay. Negative slopes go down and to the right. I could also go up 3 and to the left. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Up 3, left 4 as well. Okay, that will also give me a negative slope. So once I have these coordinates, I can plot them. And there is the graph of my line. Negative 3 over 4x minus 4. Okay. If you are given intercepts, like number 12, we will plot our x-intercept at negative 3. We will plot our y-intercept at negative